Bright QT. Every student matters.
Now let's move on to the types of hydrocarbons. There are three types of hydrocarbons. The first one is called as alkanes. Alkanes are hydrocarbons in which carbon bonds with itself with a single bond only. So this type of hydrocarbons are called as alkanes. Very simple. You attach the carbon atoms and then you fill the remaining valency with hydrogen atoms. You know that carbon has 4 valencies. So what you do is that you see how much valencies are already filled in this particular atom. 2 valencies are already filled by bonding with carbon. The remaining valencies will be filled by bonding with hydrogen. So if you're given the number of carbon atoms, you first attach them in the series and then you fill the remaining valencies with hydrogen. Okay. So as you can see here, this formula that can easily help you derive the formula of alkane. CnH2n plus 2. This is because n number of so n here is 3, right? So there are 3 carbon atoms. There will be 2n types of hydrogen and 2 attached in the end. That is why 2n plus 2. So it will be C3H, 2 3s are 6, 6 plus 2 8, H8. This is an alkane. There are different types of alkanes based on the number of carbon atoms in the series. And here is the list. So when there is only one, then it is called as methane. When there's 2, then it's called as eth. So you remember the prefix. It's meth, it's eth, prop. The ane will remain constant for all alkanes. So if it is an alkane, then there will be ane in the end. But the prefix changes based on the number of carbon atoms. So you have to remember these. For 1 it is meth, for 2 it is eth, for 3 it is prop, for 4 it is but, spent for 5, hex for 6, hept for 7, oct for 8, non for 9, and finally dec for 10. It goes on further, but only till 10 is required for your curriculum. So what you've understood so far is that the first type of hydrocarbons are called as alkanes. They are represented by this formula of CnH2n plus 2. Based on the number of carbon atoms, they are called methane, ethane, propane, butane, pentane, hexane, and so forth. And now let's move on to the second type of bonds. This is alkene. Alkene is when carbon bonds with itself with a double bond. So even if a single double bond is present in the element, then it is called as an alkene, right? So for example, this, as you can understand, 2 carbon atoms are necessary. So the smallest meth will not exist in methane will not be anything because it cannot form a double bond with hydrogen, and there need to be 2 carbon atoms to form one double bond, right? The remaining valencies again filled by hydrogen. The formula is Cn. The formula is Cn H2n, right? So so there are 2, and the remaining valencies here will be filled with hydrogen. And here also the prefix used will be ane, and the prefix used here will be ane. It was ane for the previous one, and here it will be ane. And the prefix used, the suffix will be ane, and the prefix will be based on the number. So based on the number, it will be ethene, propene, butene, pentene, heptene, hexene, like that, right? Now let's move on to the third type, which is alkyne. Alkyne is when carbon forms a triple bond with itself, and the remaining valency again filled with hydrogen. This kind of bond is called as alkyne. Here the prefix again will be based on the number. So number will decide the prefix, and the suffix will be based on the bond, which is ine. Ine will be the suffix. So if there are 2 carbon atoms, like here there are 2 carbon atoms, so it will be called as ethyne. If there were 3, it would be called as propyne, so on and so forth, right? So let's just revise what we have covered so far. We have discussed that carbon can exist in its pure form, and it can exist in compounds with other elements. It forms various elements. It forms various compounds because of 2 properties: catenation and tetravalency. The first compound that we'll be studying, which is also very common, is hydrocarbons, and there are 3 types of hydrocarbons: alkanes, alkenes, and alkynes. Alkanes have single bonds between carbon atoms. and we've studied that there are different prefix used to indicate the number of carbon atoms. Alkenes have double bonds and alkynes have triple bonds. The suffix remain common for all three. The prefix remain common for all three, and the suffix changes. It's "-ane" for single bond, "-ane" for double bond, and "-ine" for triple bond. Right? Now let's move on to what are isomers. We have studied this structure, right? We have studied that carbon can exist in form of 4 elements of carbon atoms attached with each other, with different valencies being filled in by hydrogens, right? But what if this same structure existed in another form? What if the same structure was there, but it was formed differently? So this is something that actually carbon shows. It can actually form cyclic compounds and branch compounds. I told you this before when we were talking about catenation. So what carbon can do is it can form a branch like this. So here, although here also there are 4 carbon atoms and here also there are 4 carbon atoms, but this is a branch structure. The structure is different, but the structure is different, but the chemical composition is same. The number of atoms is same. It can also exist in form of cycles. This is called as cyclopentane. One of the common and one of the most useful forms of carbon which exists in form of cycle is benzene. Benzene has 6 carbon atoms. Alternate bonds are double, right? So each carbon has 1 double bond and 1 single bond, and the remaining valency is filled in by hydrogen. So each element gets attached to 1 hydrogen. So the formula here goes C6H6. This is called as benzene.